Okay, I want to work on a few select problems from number 10 in the Klein's Organic Chemistry textbook. And so we want to name these alkanes and cycloalkanes. So the first step is always to find the longest parent chain, and remember the rules for doing that. When there's a choice, you want to select the most complicated, that are most branched, the ones with the most substituents. So if I number this chain 1, 2, 3, 1, 2, 3, I'm going to always have a methyl group on carbon 3. But if I name it this way, I'll have a carbon at carbon 4. If I number it the other way, I'll have just a nothing at carbon 4. So this is the best way to number it. Okay. I won't illustrate and highlight all the wrong ways to name this, but we have a methyl group at 6. We have a methyl group at 4. And we have a methyl group at 3. Now, a parent chain with 8 carbons is called octane. So to assemble this name, we use 3, 4, 6. And remember, when you have more than one of those substituents, you can just combine them all. And so we would call this trimethyl. So the trimethyl indicates where all those 3 methyls are, with the 3 and the 4 and the 6. And then we just write the parent chain, octane, at the end of this guy. Okay? Letter B. So we want to identify the longest chain. There's just 4 carbons there. Oh, I don't want to do this one from Klein, because this is the... Okay. Number C, letter C. So we've got our longest chain. We have 7 carbons that we could identify as longest chain. But remember that you want to identify the one that provides the most branching or most substituents. When you number, you want to number with lower numbering. Okay, so the first substituent ends up at carbon 2. If we numbered it the other way, the first substituent would be at carbon 1, 2, 3, 4, carbon 5, and that would not be good. That's not the lower numbering way. So we got a methyl group at carbon 2, and at carbon 3 we have an ethyl group. Now when you alphabetize, you want to alphabetize based on the letter. So when we assemble this name, we want to say 3-ethyl, 2-methyl, and then the parent chain, there's no spaces or anything in here, you just want to jam it all together, heptane. 7 carbons is heptane. Now remember, you always need a hyphen in between a letter and a number. So that's the full complete name for this one. Part D, we want to select the longest chain with the most branching. So 5 carbons, any which way you do it. Because of this very symmetrical molecule, it really doesn't matter which way you highlight the longest chain. I'm going to do it this way. And if we number it the other way, it's the same. So I'll stay with green. That's a nice color to work with. We've got a methyl group at carbon 2. We've got a methyl group at carbon 4. And this huge thing right here, it's commonly referred to as an isopropyl group, and that's at carbon 3. So let's go ahead and alphabetize this. When you're alphabetizing isopropyl, it's kind of very confusing. But iso just indicates kind of the shape or the isomer or the geometry of the propyl group. So you actually alphabetized based on the P, not the I. If you have an instructor that's teaching you organic chemistry that cares about that, you need to remember that rule. Okay, so let's go ahead and start alphabetizing. So we're going to have methyls, which is M, before propyls. So we want to do 2,4-dimethyl. Remember, when you have two methyl groups, you combine them with the use of a di, but you still need a number for where those methyl groups are located. And then we would have the isopropyl group. And then we would have a pentane at the end of this. Okay, pentane is 5 carbons. That's our longest chain. All right. This one, it's tempting to say that's a tert-butyl group, but please don't do that. Remember that if you select the longest chain, it could be 6 carbons running from left to right with only one substituent, that tert-butyl group. Or what's more appropriate is that you select the longest chain that has the more substituents. That's also 6, and that has a lot more substituents, doesn't it? It has a methyl, an ethyl. Now when you count this, you want to count beginning from this end to place the substituents at a lower numbering. So we've got a 2-methyl. We've got a 2-methyl. The 2 refers to the carbon number. And we've got an ethyl group at carbon 3. So when we alphabetize this, we want to, E comes before M. So we want to start this off by writing 3-ethyl. Okay? And always use your hyphens in between numbers and letters. And now remember, when you have 2 methyl groups, you can say dimethyl, but you need numbers for each of them. Even if they're at the same carbon, you need a number for the first methyl group and a number for the next methyl group. So this is 2, 2 hyphen dimethyl. I'm running out of space here. And the longest chain is 6. That would be pentane. Okay? Now, I know what you're thinking. Perhaps some of you are thinking that D comes before E in the alphabet. But D is not the name of a substituent, it's the number of the substituent. So what you're supposed to alphabetize is the name of the substituent. Okay? Ethyl is E, methyl is M, so ethyl comes before methyl. Okay? So don't worry too much about this dies or tries or whatever, okay? This molecule looks pretty complicated. So there are 2 things you want to do when you have a ring. You want to count the carbons in a ring. That's 1, 2, 3, 4, 5, 6. Or you want to count the carbons in the longest chain that might be off the molecule. And that's 8. So our parent chain is right here, okay, in a weird-looking rectangle. And the substituents are going to be circled. Okay, I think we know what methyls and ethyls look like by now. This thing is called a cyclohexyl group. Okay, so make sure it ends in a YL if it's a group. Now we want to number the longest chain so that our first substituent is at a lower numbering. So we number it from right to left in this case. Okay, we have a 6-methyl group. We have a 4-ethyl group. We have a 5-ethyl group. Okay, and we have a 2-cyclohexyl group. So alphabetization for this looks quite fun. We've got C, then E, then M. Okay, so we'll start this off. I'll write it down here where I have a little bit more writing space. So this is going to be 2-cyclohexyl hyphen, and then I want to do my ethyl because E comes next in the alphabet, and then M is last. Now there's a 5 and a 6. There's an ethyl group at carbon 5 and carbon 6 of my parent chain. So I'm going to combine these two with the use of di. Okay? So 5,6-di methyl. Okay? And again, we don't abbreviate the D. We don't do that. Okay? We abbreviate based on the name of the substituent. At the end, we add the word parent octane. Okay? So it's a pretty lengthy, long name there. That's what we got. All right, this molecule is pretty long, but let's highlight the longest chain. It just zigzags on through here. And, we would number that. Okay. And these are all methyl groups, so that's pretty easy. We've got one at carbon 2 and carbon 2, carbon 6, 7. So we got 1, 2, 3, 4, 5, 6. So 6 is hexa, methyl, and then nonane is the name of my parent chain. So this is kind of weird, but remember, if you do hexamethyl, you need numbers for all the locations of the addresses of where all those methyl groups live. All right, this molecule here, let's number this from left to right. Let's number this from right to left and then compare. No matter which way you number it, you're going to have a carbon you're going to have a methyl group on carbon number 2, and you're going to have 2 methyl groups at carbon 4. So either way is okay. This is a very symmetrical molecule. And so, if we name things, we have let's use the, let's number it from left to right so we can orientate all our eyes. So there's a methyl group at carbon 2. There's a methyl group at carbon 4. There's a different methyl group at carbon 4. And there's another group at carbon 6. Remember, we're using the black letters, the black numbers here, or numbering from left to right. So we got 1, 2, 3, 4 methyl groups. That's tetramethyl, right? So let's assemble the name. 2, 4, 4, 6, tetramethyl. And the parent chain is 7, so that's heptane. Hept is 7. Okay? All right. Let's select the longest chain here. It looks like it just zigzags on through. Now this is a little bit different because let's number it from left to right. We have a methyl group at carbon 2, carbon 2, carbon 4. Let's number this from right to left. The alternative would be a methyl group at carbon 2 and carbon 4 and carbon 4. So there's a tie at carbon 2, but for carbon, the next guy here, it wins out, right? 2 is less than 4, so this is better. 2 is better than 4. Okay, so we want the yellow numbers. Let's use a different colored pen here. So 2, 4, trimethyl, okay, is how we indicate where these 3 methyl groups are. And the parent chain is going to be pentane. Pent means 5. All right. Letter M. Now it's tempting just to do this from left to right and think of that as a tert-butyl group. We don't want to do that. We want to zigzag through the molecule. And so when we do this, oops, I made a mistake. I was confusing this with a different problem. Going this way has 6 carbons. Going straight across the board has 7. Okay, so we actually want to highlight these 7 carbons here. So the parent chain is 7, or heptane, and this group is commonly referred to as a tert-butyl group. Now, where is that located? Is it located at carbon 4 if I number it this way? Or is it located at carbon 4 if I number it that way? Well, yes. So we would name this 4 tert-butyl. And remember that tert-butyl has a hyphen between the tert and the butyl part. And you always use a hyphen between numbers and letters. So this is tert-butyl. 7 is heptane for the parent chain. Okay? All right, these molecules are getting more difficult, aren't they? So we want to select the longest chain. With the most number of substituents. So we would all agree that we should start going this way, okay? And then you have a choice. Do we go up or do we go straight across? Now what you want to do is go up, because that creates 2 substituents at this part of the molecule rather than just 1. So we want to zigzag the longest chain kind of in that fashion. Now, let's go ahead and number things. I think it's easy to see that we should start numbering here because the first substituent ends up on carbon 2. So this is the best way to number the longest chain, or the parent chain in the molecule. This is a decane. It's a pretty high number. And let's go ahead and number and put the location for each of the substituents. So a 3-ethyl, a 2-methyl, a 4-methyl, and this is an isopropyl at carbon 6. Now, that reasons that are beyond me, we actually, okay, that's wrong. We needed a hyphen there between the 6 and the iso part. But we don't have a hyphen within the word isopropyl. Now, as I was trying to say, reasons that are beyond me, we actually alphabetize on the P of the isopropyl group. So these ethyls and methyls are going to come before it, and the isopropyl is going to come last. So first comes the ethyl group because it has E, and then we have the methyl groups. We have 2 of them, so we're going to position them all in here now. And remember, when we have 2 methyl groups, we can use dimethyl to simplify the name a little bit, but we still need a number for each of the methyl groups. And then at carbon 6, we have this isopropyl group. Finally, we get to the parent chain, and we said that was 10. That's a decane. So that's the full, long, complete name of this compound. This next molecule eight carbons, zigzags that way. Or we could zigzag this way. So this circled way has 3 substituents. I'll use a really light colored ink for the other way. And if we just go straight across the molecule this way, this is also 8 carbons, but I only have 2 substituents. Okay, so this way I have 2, maybe I'll write up here, 2 substituents, and in red I have 3 substituents. So this is the best way. The more substituents wins out. And if we consider the red chain, I'll highlight that just to make sure it's more clear. We're looking at this as the parent chain, and the 3 substituents that are hanging off of this red parent chain are circled in blue. So we'll now number the longest chain, and we probably want to begin here To put a lower numbering on the first substituent, we've got a methyl group at carbon 2. We've got an ethyl group at carbon 3. And we've got another ethyl group at carbon 5. So let's look at this. We want to alphabetize. E comes before M. So we want to put 3, 5. And then we use di when we have two substituents. So we want to do diethyl. And then we want to do 2-methyl. And then, as we've been learning, 8 carbons in the longest chain is going to be an octane. Okay. I just want to remind everybody that we alphabetize based on the E of the ethyl group and the M of the methyl group, not the D of the di or the T of a tri if you had a tri. Okay? So that's the name of this molecule. This molecule is a ring. There's only 3 carbons out here as the longest chain, so 5 wins out over 3. So here are the 5 carbons. The parent chain of this is going to be a cyclopropane, and these 2 groups are commonly referred to as isopropyl groups. When you number it, you want to number it starting with one of the substituents, and we number it in the shorter manner. Let me explain to you what that means. We don't number it this way because the 2 numbers that identify where the isopropyl group are going to be higher numbers. 1 and 4 is higher than 1 and 3. So 1 and 3 is the way to go. And remember, if you have 2 of anything, you can use commas and di to indicate where those are located. So this is 1, 3, di isopropyl, and then cyclopentane. All right, last but not least, we have a molecule. So let's just see how we could number this. 1, 2, 3, 4, 5, 6, 7. Going that way. 1, 2, 3, 4, 5, 6, 7. Going that way. So here I'll use those different colors to figure out which way to do that. If I do it this way, I'm going to have 3 substituents. And if I do it with magenta, I only have 2 substituents. So this is the way to go in yellow. So I'm going to just highlight that longest chain there. So 7 carbons, and also we have more substituents. Let's identify those now. Well, let's count the carbons here. And I want to number it from left to kind of right to position the substituents at lower numberings. So we have a 2-methyl group. We have a 3-ethyl group. And we have a 5-methyl group. Okay. When we alphabetize this, we want to start off with 3-ethyl. Then we want to deal with the methyl groups. There are 2 of them, so we can combine these with the use of a comma and di to write dimethyl. Okay? It doesn't matter where those numbers are. It could be 2 and 12, whatever, as long as we're just indicating where they are. Again, we're alphabetizing based on the M of the methyl and the E of the ethyl. We don't worry about the D. So that's it. And then we need to deal with the parent chain. The parent chain is 7 carbons, so that's going to be heptane. Thanks for watching. Thumbs up, and please subscribe if you like.